Before the scientific revolution, ancient people had many different ways of explaining the changing seasons. A variety of religious stories and astrological phenomena have been used since the beginning of humanity to explain the fact that Earth experiences well-defined seasons of hot and cold every year, unless you live in Georgia. But what really causes the seasons? Nowadays, most people know that 1 year is the time it takes Earth to orbit the Sun once, and they correctly assume that the seasons have something to do with that orbit. Where many people go wrong is when they attribute the change in temperature to the Earth's distance from the Sun. In their defense, it makes sense. After all, being further away from the giant fiery ball that sustains life would make Earth colder, and being closer would make it warmer. This assumption, however, is inaccurate. We know that Earth stays about 93 million miles away from the Sun at all times, in a relatively circular orbit, so the Earth's seasons cannot be explained by the distance from the Sun at any given time in the cycle. Then how can we explain the obvious cyclic pattern of temperature change on the Earth? The real explanation has to do with the Earth's obliquity. The word oblique means neither perpendicular nor parallel, but sort of tilted. So saying the Earth's obliquity is the same thing as saying the Earth's tilt. Why did scientists come up with a fancy word when they could have just said tilt, you ask? In all honesty, they probably just wanted to impress their friends. But back to the issue of the seasons. Why does obliquity matter? It all has to do with the combination of obliquity and orbit. Let's look at one orbit around the Sun, starting on September 21st. September 21st is a special day called an equinox. To be more specific, it is the autumnal equinox because it happens in autumn. The day of September 21st is exactly as long as the night. Earth's southern and northern hemispheres get exactly the same amount of sunlight, and the Sun is directly over the equator. As the Earth moves along its orbit, the Sun is able to heat the southern hemisphere more and more, while the northern hemisphere gets less and less sun. On December 21st, known as the winter solstice in the northern hemisphere because it occurs in the northern hemisphere's winter, the northern hemisphere experiences its shortest day. The southern hemisphere, meanwhile, has its longest day and calls it the summer solstice. But we don't talk about that because America's in the northern hemisphere, so who cares about the other half? As the Earth continues, it reaches another equinox on March 21st. This is called the vernal equinox because it happens on the American hemisphere's spring, and spring doesn't sound as fancy as vernal. Finally, the Earth reaches the summer solstice for the American hemisphere on June 21st. This is the American hemisphere's longest day. As you can see, during this quarter of the Earth's orbit, the Sun shines primarily on the American hemisphere and causes summer to occur there. So now you know what really causes the seasons. Next time one of your friends says something misinformed about the reason for the seasons, make sure to correct them. It's a surefire way to impress and really makes you the life of the party.